Greetings of the day. So today we are going to discuss module 1 stress and strain. In that we are going to discuss how to find out the deformation, stress, strain, and as well as the unknown parameters like diameter, internal diameter, and as well as the external diameter. So first, I'm going to take a problem. So the problem is like this: a circular rod of diameter 20 millimeter and 500 millimeter long is subjected to a tensile force 45 kilonewton. The modulus of elasticity for steel may be taken as 200 kilonewton per millimeter square. Find stress, strain, and elongation of the bar due to applied load. So here the given is a circular rod. Given is a circular rod. Given is a circular rod of diameter 20 millimeters. So given is a circular rod. So the cross section of the bar is a circular in a section, and its diameter is 20 millimeter and its length is 500 millimeter long, and it is subjected to a tensile force, and it is a subjected, the bar is subjected with a 45 kilo Newton, and the modulus of elasticity, Young's modulus, or we can say Young's modulus for the steel is given is 200 kilonewton per millimeter square. And here it is asked to compute the stress, strain, and elongation. Here it is asked to compute the stress, strain, and elongation of the bar due to the applied load of 45 kilonewton. So let me record the given data. The diameter of the bar is 20 millimeter and the length is 500 millimeter. So length, original length, so we are considering L naught is equal to 500 millimeter, and load is 45 kilo Newton. We can write 45 into 10 power 3 Newton. Kilo is 10 power 3. And Young's modulus of the steel. Young's modulus of the steel may be taken as 200 kilonewton per millimeter square. So Young's modulus E is equal to 200 kilonewton per millimeter square. So here kilo is given. So we can take it as 200 into 10 power 3. Kilo is 10 power 3 Newton per millimeter square. And here it is asked to compute the stress, strain, and elongation. So stress is sigma. We are going to denote stress by sigma and strain by epsilon. And the Young's modulus E and the elongation is dl. So we know stress is equal to load by area. Here once again, here I'm taking whatever the given data, diameter is given. So let me construct a figure. So it is on a circular bar. It is subjected to a load of 45 kilo Newton. Diameter is 20, length is 500 millimeter, load is 45 kilonewton, and Young's modulus is 200 kilonewton. So we are converted in terms of Newton per millimeter square. So 200 into 10 power 3 Newton per millimeter square. Initially, we are going to compute the area of cross section. So we have the equation or area of cross section for a circular bar is pi d squared by 4. So we can take pi, and given is diameter of the circular bar is 20 millimeters. So 20 square d square divided by 4. So pi d square by 4, pi into 20 square by 4. So this will be is equal to 314.159 millimeter square. Area of cross section we have to specify unit with the millimeter square, because here the diameter is given in terms of the millimeter, so d square, so we'll get the millimeter square. And next we can find the stress. So we know stress will be is equal to load divided by area, and here the circular bar or the circular rod is subjected to a 45 kilonewton, so the load is 45 into 10 power 3. So load we are considering in terms of the Newton. 45 kilonewton is given. So 45 into 10 power 3 over the area of the cross section already we computed. So area of the cross section is 314.159. So this answer stress will be is equal to 45 into 10 power 3 divided by 314.159. It is going to give 143.24, and the unit for the stress is Newton per millimeter square, because we know stress is equal to load divided by area. So load we substituted in terms of the Newton, and area unit is millimeter square, so the unit for stress is Newton per millimeter square. If you are substituting load in terms of the kilonewton, if you are substituting the load in terms of the kilonewton, so the unit for the stress will be kilonewton per millimeter square. If the load in terms of the kilonewton and the area if you are substituting in terms of the meter square, so the stress unit will be a kilonewton per square millimeter. And next here it is asked to compute this strain. So we know strain will be is equal to change in length over original length. So change in length is dl and original length is l naught. In the given question, the length of the circular bar is given. Length of the circular bar is 500 millimeter, but dl, the change in the length or the deformation or extension is not given. So to find out this dl, to compute this time, we should know dl and as well as the l naught. Anyway, l naught is given, but dl is unknown. So we can compute the deformation or elongation. We can say the deformation or elongation or the extension. These are same meaning. We can say deformation or extension of the bar or elongation of the bar. So deformation, how to compute the deformation is dl will be is equal to p l naught divided by ae. So p is indicating a load, and L naught is indicating the original length, and A is the area of the cross section, and E is the Young's modulus. L naught is given in the question, and Young's modulus for the steel is given, and A already we computed area we got is 314.159 millimeter square. So we can substitute load is 45 into 10 power 3, and L naught given L naught is 500 millimeter over area of the cross section is 314.159, and Young's modulus is 200 into 10 power 3. So here 10 power 3 we can directly cancel it, and here this two zeros we can cancel it. So after substituting, you will get the deformation dl will be is equal to a 358. So this deformation is change in length. So deformation, so we can go with the unit is millimeter. So we can check it. So load is we are specified in terms of the Newton, and L naught in terms of the millimeter, and area in terms of the millimeter square, and Young's modulus is Newton per millimeter square. So here Newton will get cancelled, and here this millimeter square and millimeter square will get cancelled. So the deformation or the elongation unit will be is equal to a millimeter. So the change in length or the deformation or elongation will be is equal to 0.358. So now we can compute this strain. So strain is change in length by original length. That means dl by l naught. So dl we got is 0.358 over the original length is 500. Original length is equal to 500 millimeters. So we'll get this deformation and deformation divided by original length is this strain. So this strain value will get point triple zero 716. So for this strain there will be a no unit, because strain will be is equal to change in length by original length. So change in length is in terms of the millimeter, and original length also millimeter. So the millimeter will get cancelled. So this strain will be, it doesn't have any kind of the units. So let me recall, the given question is a circular rod of diameter is 20 millimeter and length is 500 millimeter. So its diameter is 20 and length is 500 millimeter. You can take the length is L naught is 500 millimeter, and it is subjected to a load of 45 kilonewton, and the modulus of elasticity is given is 200 kilonewton per millimeter square. So 200 into 10 power 3 newton per millimeter square. And here it is asked to compute stress, strain and elongation. Here it is asked in this question, asked to compute the stress, strain and elongation of the bar due to the applied load. So here for this we have whatever initially we calculated the area of the cross section, and again here to find the area of the cross section we need to be read question carefully, whether it is given is a rectangular or a square section or the circular. In the given question it is clearly specified it is a circular rod. So for the circular rod, so the area of the cross section is pi r square, or you can take pi d square divided by 4. So after substituting diameter 20 millimeter, we got area is 314.159. The unit for area of cross section is millimeter square. And next we computed the stress. So we know the equation, stress is equal to load divided by area. Load is 45 kilonewton, so 45 into 10 power 3, and area is 314.159. So if you are simplifying, you will get the answer is 143.24 newton per millimeter square. The stress unit is newton per square millimeter or newton per meter square. And next here it is asked to compute this strain. Strain will be is equal to change in length by original length is equal to dl by l naught, but here dl is unknown but l naught is known. So to find dl we are going to use the equation dl is equal to p l naught divided by ae. P is indicating the load and L is indicating the original length, and A is the area of the cross section, and E is indicating the Young's modulus. So load is known, length is known, area is known, and Young's modulus is known. So if you are substituting all these values, you will get the deformation or the elongation will be equal to 0.358. So now later you can compute this strain will be equal to change in length is 0.358 divided by original length is 500. So you'll get 0.00716. And let me take a second question. So the given question is like this: a hollow cylinder 2 meter long has an outside diameter of 50 millimeter and inside diameter of 30 millimeter. If the cylinder is carrying a load of 25 kilonewton, find the stress in the cylinder. Also determine the deformation of the cylinder. If the value of Young's modulus or modulus of elasticity for the cylinder material is 100 gigapascal. So here given is a hollow cylinder and its length is, it is an hollow cylinder. Length of the hollow cylinder is given, length of the hollow cylinder is 2 meter long. Length of the hollow cylinder is 2 meter long, and its outside diameter. So I'm considering the outside diameter with a capital D is equal to 50 millimeter outside diameter, and the inner diameter is small d. I'm taking inner diameter as small d or lowercase letter d is 30 millimeter. Inner diameter is 30 millimeter. If the cylinder is carrying a load of, if the cylinder is carrying a load of 25 kilo Newton, Here it is asked to find the stress in the cylinder. Also determine the deformation of the cylinder if the value of modulus of elasticity E for cylinder material is 100 gigapascal. So let me record the given data. A hollow cylinder of 2 meter long. So L naught is 2 meter. So you can write 2 into 10 power 3 millimeter. And outside diameter of the hollow cylinder is 50 millimeter. So outside diameter capital D is 50 millimeter. And inside diameter is 30 millimeter. So inside diameter, I'm considering inside diameter with the small letter d is 30 millimeter, and it is carrying a load of 25 kilonewton. So 25 into 10 power 3 Newton. And here the given is Young's modulus is 100 gigapascal. So we need to convert, or we need to keep all the units either in terms of the Newton per meter square or Newton per millimeter square. But here given is Young's modulus is 100 gigapascal. So 100 giga is indicating 10 power 9. Mega is 10 power 6, kilo is 10 power 3, and giga is 10 power 9 pascal. 10 power 9 into pascal. So 100 into 10 power 9. 1 pascal will be is equal to 1 Newton per square meter. So we can take 100 into 10 power 9. 1 pascal is equal to 1 Newton per meter square. And in the next step, 100 into 10 power 9. So now we are converting meter square into a millimeter square. So 10 power 3 into a 2 times. So 10 power 3 square means you will get 10 power 6. So finally here 10 power 6 will get cancelled. So here instead of 10 power 9, the remaining is 10 power 3. So E is equal to 100 gigapascal. Whenever the given Young's modulus in terms of the gigapascal, we can directly write 100 into 10 power 3 Newton per square millimeter. And here it is asked to compute the stress. Here in the question, here it is asked to compute, find the stress in the cylinder, also determine the deformation. So stress is sigma and the deformation is dl. Deformation of the cylinder is dl. So here it is asked to compute the stress in the cylinder and the deformation dl in the cylinder. And once again here I have taken whatever the given data in the question. Length is L naught, length is 2 into 10 power 3 millimeter, and outside diameter is 50 millimeter, and inside diameter is 30 millimeter, and load is 25 kilonewton, and Young's modulus we got is 100 into 10 power 3 Newton per square millimeter. After converting the 100 gigapascal in terms of the Newton per millimeter square, we got is 100 into 10 power 3. So here asked to compute the stress in the cylinder. We know stress is equal to load divided by area. Load is known, load is 25 kilonewton, but area of the cross section is unknown. Here in the given question is, it is an hollow cylinder, it is not a solid cylinder, it is a hollow cylinder. So area of the cross section for a solid cylinder, or for a solid bar, the area of the cross section is pi d square divided by 4. But here it is an hollow cylinder. Outer diameter and as well as the inner diameter, we need to consider capital D and as well as the small d. Outer diameter and as well as the inner diameter. So area of the cross section will be is equal to pi d square minus d square divided by 4. So here pi d square outer diameter is 50. So 50 square minus the inner diameter. Inside diameter is small d. Inside diameter is 30. So 50 square minus 30 square divided by 4. But in exam, many will do the confusion like area they will take it, and pi into they will do capital D minus small d whole square divided by 4. So you will get the wrong answer for the area of the cross section. Area will be pi into d square minus small d square divided by 4. So area of the cross section after simplifying, pi into 50 square minus 30 square divided by 4 will get 1256.6. So the area of the cross section unit is millimeter square. Area of the cross section is 1256.6 square millimeter. Now we can find out this stress. Stress is equal to load divided by area. Load is given. Load is 25 kilonewton. So 25 kilo we can express in terms of 10 power 3. So we'll get in terms of the Newton. And area of the cross section, we calculated area of the cross section, we got 1256.6, and its unit is millimeter square. So if you simplify further, 25 into 10 power 3 over 1256.6, you will get 19.9. The unit for stress is Newton per square millimeter, 19.9 Newton per square millimeter. And here it is also asked to compute the deformation of the cylinder. We know the equation. Deformation dl will be equal to P into L naught divided by A into E. P is the load and L naught is the original length, and A is the area of the cross section, and E is the Young's modulus. So dl will be equal to P L naught divided by A E. Load is 25 into 10 power 3. It is given in the question. And the L naught is given. Length of the hollow cylinder is 2 meter is given. So in terms of the millimeter, 2 into 10 power 3. So this is load, and it is length L naught divided by area of the cross section. We calculated area is 1256.6 1256.6 millimeter square, and Young's modulus is given is 100 gigapascal. So in terms of the Newton per millimeter square, 100 into 10 power 3 Newton per millimeter square. So now we can simplify further. So 10 power 3 will get cancelled, and here 2, and here you will get the 50. So 25 into 10 power 3 divided by 1256.6 into 50. So you'll get the deformation is 0.3979 millimeter. So 0.35, sorry, 3979 millimeter, because dl will be is equal to P L naught. So the load unit is Newton, and length L naught is in a millimeter, and area of the cross section is millimeter square, and Young's modulus is Newton per millimeter square. So this millimeter square and this millimeter square will get cancelled, and this Newton and this Newton will get cancelled, and it is remaining ended with millimeter square. So the given question is a hollow cylinder 2 meter long, length is 2 meter, outside diameter of 50 millimeter and inside diameter of 30 millimeter. If the cylinder is carrying a load of 25 kilonewton, find the stress in the cylinder. Also determine the deformation of the cylinder. Here it is asked to compute the stress and deformation of the cylinder. So stress is load divided by area. Load is known but area was unknown, so we calculated area. So the calculated value for the area of the cross section is 1256.6 millimeter square. So if you substitute load divided by area, we will get the stress will be is equal to 19.9 Newton per square millimeter. And here it is also asked to determine the deformation in the cylinder. So we have the equation for the deformation or extension or elongation is dl will be equal to P L naught divided by AE. And if you substitute load, length of the cylinder, area of the cross section, and Young's modulus, so we'll get the deformation or elongation is 0.3979 millimeter. And now we are taking a one more problem. So the problem is a hollow steel tube 3.5 meter long has external diameter of 120 millimeter. In order to determine the internal diameter, the tube was subjected to a tensile load of 40 kilonewton, and the extension was measured to be 2 millimeter. If the modulus of elasticity for the tube material is 200 gigapascal, compute the internal diameter of the tube. Here given is a hollow steel tube. The material of this tube is steel and its length is 3.5 meter long. Given is it is an hollow tube. It is a hollow tube. It is not a solid rod, or it is a hollow tube, and length of the tube is 3.5 meter, and it is having a external diameter we are going to specify with the capital D is 120 millimeter, and here it is asked to determine the internal diameter. In order to determine the internal diameter, and the tube was subjected to a tensile load, the tube is subjected to a tensile load of 400 kilo Newton, and its extension was measured. After applying the 400 kilo Newton with the tensile load, the tube is getting elongation. The tube is getting elongation. The tube is getting elongation. Its dimension is given. So the elongation or deformation dl will be is equal to a 2 millimeter. So the tube was subjected to a 400 kilonewton. After the application of tensile load of 400 kilonewton, the tube is getting extension or the deformation. With the tensile load, the tube is getting extending or lengthening, or it is getting the deformation. dl will be is equal to a 2 millimeter. If the modulus of the elasticity for the tube material is 200 gigapascal, compute the internal diameter of the tube. Here length L naught is given, length of the tube 3.5 meters, so we can take 3.5 into 10 power 3 millimeter, and external diameter is 120 millimeter, so capital D is 120 millimeter. In order to determine the internal diameter, so here it is asked to compute the internal diameter small d, and the tube is subjected to a load of 400 kilonewton. 400 kilonewton, so we can express in terms of the newton is 400 into 10 power 3 newton, and its extension was measured. After the application of the 400 kilonewton with the tensile load, the tube is getting the deformation or extending or lengthening. Length is increasing with the 2 millimeter. The deformation with the application of the 400 kilonewton, the tube is getting increasing or deforming with a length of 2 millimeter. And if the modulus of the elasticity for the tube material is 200 is given, E is 200 gigapascal, so 200 giga is 10 power 9 pascal, so 10 power 9 1 pascal is equal to 1 newton per 1 Newton per square meter. So we can write as it is 200 into 10 power 9. Instead of Pascal, we can express in terms of the Newton per square meter, because 1 Pascal will be equal to 1 Newton per square meter. And next 200 into 10 power 9 meter, we have to convert in terms of the millimeter square, because here this length or deformation it is in the millimeter, and the external diameter is in the form of millimeter, and length also we are converting in terms of the millimeter. So we have to keep all the units with the same whatever the magnitude. If it is meter, all are in a meter. If it is millimeter, all or everything should be, or all the data with respect to a millimeter only. So 200 into in terms of meter to a millimeter, you can divided by 10 power 6. So this 6 will get cancelled, remaining with a 10 power 3. So 200 into 10 power 3 Newton per millimeter square. It is very simple. Whenever it is given in terms of the gigapascal, we can express in terms of 10 power 3 Newton per millimeter square. We need to add 10 power 3 to the gigapascal to express in terms of the Newton per square millimeter. And here it is asked to compute the internal diameter of the hollow tube. So given data are 3.5 meter length and external diameter is 120, load is 400 kilonewton, and deformation is 2 millimeter, and Young's modulus is 200 into 10 power 3 Newton per square millimeter. So the area of the cross section will be is equal to pi into d square is known. Outer diameter is 120 square minus the inner diameter is unknown. So d square. In the question, it is asked to compute the inner diameter of the hollow tube divided by 4. So pi into 120 square minus d square divided by 4. So pi by 4 you can simplify, so area will be is equal to pi by 4 will be is equal to 0.7854 into 120 square minus inner diameter square. So area will be is equal to 0.7854 into 120 square minus d square. So we know deformation dl is equal to p l naught divided by ae. P is the load, l naught is the length, a is area of the cross section, and e is Young's modulus or modulus of elasticity. Young's modulus or modulus of elasticity. So in the question, the deformation, when the steel hollow tube is subjected to a load of 400 kilonewton, it is getting a deformation of 2 millimeter. In this problem, deformation dl is given is 2 millimeter, and load is whatever the applied load is tensile 400 kilonewton, 400 into 10 power 3 Newton, and length is 3.5 meters. So 3.5 into meter, we need to convert in terms of the millimeter. So 3.5 into 10 power 3 millimeter divided by area of the cross section we got is 0.7854 into 120 square. Outer diameter is known. Here it is asked to compute the inner diameter of the hollow tube, and Young's modulus is 200 into 10 power 3. 200 into 10 power 3. So here 10 power 3 will get cancelled, and 200 here 400. So 200 by, so 400 by 200 is 2. So we'll get 2 into 3.5 is 7 into 10 power 3 divided by 0.7854 120 square minus d square. So this will be is equal to a 2. So we can cross multiply. So 2 into 0.7854 into 120 square minus d square is equal to 7 into 10 power 3, 7 into 10 power 3. So if you further simplify, you will get the d square will be is equal to 19887 divided by 2. So d will be is equal to 99.71 millimeter. So here it is asked to compute the internal diameter of the hollow tube. Internal diameter is 99.71 millimeters. So we can cross check it whether we got the correct answer or not. Anyway, the outer diameter is 120 millimeter. Obviously, the inner diameter should be a less than the 120 millimeter. So here we got, so to cross check whether we done proper whatever the calculation in the calci of we done the proper substitution or not. So d we got is 99.71 millimeter. So let me recall the given question is a hollow steel tube 3.5 meter long, length is 3.5 meter, and external diameter capital D is 120 millimeter. And in order to determine, here it is asked to determine the internal diameter. Internal diameter is small d. This tube was subjected to a tensile load. The tube is subjected to a load of 400 kilonewton, and The extension was measured with the application of 400 kilonewton. The tube is getting elongated with the 2 millimeter. And if the modulus of elasticity for the tube material, for the steel material, the modulus of elasticity or Young's modulus or E is equal to 200 gigapascal. And here it is asked to compute the internal diameter of the hollow tube. So first we can find out the area of the cross section. Here unknown is d square, so we kept as it is in terms of the d square. And next dl is equal to extension or the deformation. Dl will be is equal to pl naught by ae. So this deformation is given. Deformation is 2 and load is known, l naught is known, area is known, e. In the area, the parameter is small d. Unknown parameter is small d. So we got the internal diameter will be is equal to a 99.71 millimeter. So thank you.